In today's video, we'll be looking at parallel and perspective mappings. If you're new here, welcome to the Hive School. My name's Rich and I'm making these videos to help you one-up your live event production workflows. In parts 1 and 2 of this series, we told you all about direct mappings and feed mappings. If you've missed either of those, then I've no idea what you're doing here in part 3, but hey, I'm not here to tell you how to live your life. If you want to start eating your banana in the middle, then you do you. Link in the description below for those people who want to see the first 2 parts. As I mentioned, today we're going to be focusing on parallel and perspective mappings. The direct and feed mapping types that we showed you previously both work in 2 dimensions. They're taking 2D content and applying it to your screens using a process that corresponds to the UV coordinates. Even when your screens are more complicated shapes, ultimately what Disguise is doing in the background is mapping your content back onto the UV of that model. The next 2 mappings that I want to show you override the UV map and use the position of your models within the stage to inform the way the content is drawn onto your screens. Let's get into it. If you're familiar with other 3D software, what Disguise calls a parallel map, other software would call a planar map. This might be a useful point of reference for anyone who understands that workflow. Hopefully by now we don't need to recap how mappings are created, however we're going to do it anyway as this wouldn't be a very good tutorial if we started at step 2. So once again, we access the mapping menu via a layer on the timeline. We start by giving our new mapping a name before selecting the mapping type that we want. Today we're going to make a parallel map. The first thing you'll see on the stage is the white outline of a helper with your content inside. As we've done before, we'll start by setting the mapping resolution to the size of the content. However, when you try and add your resolution, you'll notice that unless you coincidentally have a file with the same aspect ratio as the default helper, which by the way is 4 by 3.2, you won't be able to set both numbers correctly. Disguise constrains your input resolution to match the aspect of the default mapping. You need to go down to the lock parameter and turn it off. You'll then be able to set your resolution correctly without Disguise controlling the other number. If you look at the stage, you'll notice that with the aspect lock off, Disguise has squashed your content into the helper. Although we've changed the resolution of your content, the size of the mapping still remains the same. To address this, go to the size parameter of the mapping. The first number represents the width in meters and the second number represents the height in meters. What I like to do is set a size that relates to the aspect ratio of your content. So for this test card, let's set the mapping size to 16 meters by 9 meters. Don't worry if this is bigger than the screens you have on your stage at the moment, we're going to fix that shortly. The last step is to set the lock parameter back to aspect. This will lock the aspect ratio of your content, allowing you to modify the size of your mapping without stretching or squashing your pixels. If you're not familiar with aspect ratios, I encourage you to review the first video in this series, where I covered them in a lot more detail. You can always leave a comment if you've got any specific questions too. Even with all these changes, your content still won't be mapped to any of your screens. To fix this, we need to tell the mapping which screens we want to affect. If you look in the visualizer, you'll see that the screens we added will turn red where the parallel map doesn't touch them. The red on the screens will help to ensure that we get full coverage when we come to lining up our mapping across the screens. So the parallel mapping takes its name from its function. Imagine pushing your content into the stage from this white rectangle that is parallel to all your screens. You can move the rectangle around by changing the X, Y and Z values in the mapping dialog. There's a number of places in the Disguise interface where you'll have 3 unlabeled values that represent X, Y and Z. For example, when you right-click a screen, you'll see the offset value has 3 unlabeled boxes. Each one of these also represents the X, Y and Z location of the screen in meters. If you're following along, I understand the 16 by 9 meters might be way too big for your stage setup. Now is the point where we can correctly set the size of the mapping. With the aspect lock back on, click on the width box and scroll your mouse wheel. You'll note that the height changes too, maintaining the correct aspect ratio for your content without stretching or squashing your pixels. The final step in setting up your mapping is to adjust the size and position until you're satisfied with how your content is covering your screen. If you've been enjoying this series on Disguise content mappings and you think we've earned it, we'd love you to subscribe to our channel so that you don't miss out on future videos. When teaching mapping types, we often present parallel and perspective mappings together because they function in a very similar way. While a parallel mapping pushes content onto the stage using a plane, a perspective mapping achieves the same effect using a perspective. When adding the perspective mapping, you'll notice that the helper no longer displays the white square, but instead shows a camera frustum. The eye point or origin point of the content is located at the apex of the frustum. The eye point controls are another example of X, Y and Z values in the Disguise interface without any labels. By moving the eye point, you can change the position of the content on the stage. The aspect ratio of the perspective map are determined by the mapping resolution that you set. In many ways, I wish the parallel map worked a lot more like this, as there are fewer steps involved in getting it work correctly. Similar to the parallel map, the final step in setting your perspective mapping is aligning it with your screens on your stage. I've intentionally arranged the screens on my stage to showcase how perspective mapping functions. As you can see, the content scales up as it moves further away from the eye point. I'd like to highlight the field of view parameter in the perspective mapping. It not only allows you to scale your perspective map while maintaining the correct aspect ratio, but it also serves another very important purpose. If your content is generated in 3D, then you can input the same position and field of view as the camera used to render your content. This will project the content back into the scene exactly as it was created, without the need to bake down to a UV for use with the direct map. Explaining this entire workflow would significantly lengthen this tutorial, but please leave a comment if you'd like to see it covered in a future video. This not only marks the end of this tutorial, but also the conclusion of our series on Disguise content mappings. It's worth noting that Disguise has 6 additional mapping types, however, the 4 that we've covered in the last 3 videos are the most commonly used ones. They're definitely the ones that I would start with if you're learning the software. Although this is the end of the line for our deep dive on content mappings, we'll be back with more tutorials to help you one-up your live production workflows very soon. Take care.